you and welcome everybody. My name is Thamer Al-Zuriqat. I'm from the Hamburg University of Technology, and today I will be presenting to you our work regarding the diagnosis of simultaneous sensor faults in structural health monitoring systems. So before we start, first, what is structural health monitoring? So structural health monitoring is a non-destructive evaluation technique that uses monitoring data from sensors to evaluate the conditions of your monitor structures, such as a bridge, a building, or whatever. And here's an example of a typical wireless SHM system. So you would have your sensor nodes, and those sensor nodes are acquiring data, and these data contains information which later you can translate into knowledge about your structure. Like now, why do we use SHM systems? And the first goal or main goal of SHM systems is safety. So we don't want scenarios like this where structures fail, because, for example, this is a night ring in Germany that failed because of a snow overload on the roof. And the other reason we use SHM systems is because of cost efficiency. And here we can see one of our colleagues inspecting a bridge, and this is a visual inspection. And for me, until now, I think SHM systems cannot replace visual inspections yet, but they complement them. So SHM systems have, in general, there is a problem with sensor faults. And sensor faults may compromise the reliability of your system. So you would have faulty data, and you would have such type of faults. So maybe you would have a complete failure of your system or of your sensor, sorry. Maybe you would have outliers, maybe you would have some noise. And the idea is, these faults may come from maybe a hardware or software malfunction, power outage, or environmental impacts, or in case of wireless sensor nodes, signal interference. So what we want to do is to diagnose these faults. And to do so, in analytical redundancy, we have 4 steps to do so. One is to detect the faults, so to recognize that there is a fault in the first place. Second is to isolate it, is to know exactly where this fault is coming from. And third is to identify the fault, is to know which nature this fault is, like what type of fault it is, and to accommodate this fault, so to replace it with a correct value. However, in the research, there is a lot of ways to do so, but they consider only a single fault occurrence, and they do not consider multiple fault occurrence. And in some cases, those multiple faults occur simultaneously. So we came up with the idea of adaptive fault diagnosis based on analytical redundancy. So first of all, before I would like to explain to you a little bit how fault detection works using artificial neural networks. So this is an exemplary structure. This exemplary structures have 4 sensors, and what we would do is we would train 4 models. And those 4 models, each model of them would be responsible for a single sensor. So in this case, model 1 would be trained to predict output for sensor 1 based on data coming from sensor 2, 3, and 4. And the same goes for sensor 2, again the same for sensor 3 and sensor 4. However, what happens is, what if both sensor 4 and 1 fall at the same time? So you would have a nonsense input, and as a result you would have a nonsense output, so it doesn't work with support. So this is where we came, as I said, again with the AFTA approach, and I'm going to explain this step by step. So first of all, we have an initialization stage. In this initialization stage, we collect data, and these data, we process them, we clean them, and then we train our models. So we do again the same idea with the fault detection, and then once we detect a fault, we record a fault timestamp. And this fault timestamp is being sent to the next step, which is a fault isolation, and then we look at each sensor separately. And then we compute the moving average of each sensor, like for a defined period, and then we can isolate the sensor. Then now, based on how many sensor or faulty sensors we have, we can adapt our models. And I'm gonna make in the validation test, I'm gonna show it to you how it adapts. So here's our validation test. It's an SHM system installed on a bridge in Germany, and it's consists of 15 spans and have a total length of almost 870 meters. And those sensors, like the 10 sensors we see here, are temperature sensors embedded in the concrete. So as I said, first we trained 10 models, and this is an example of model number 3, which is responsible for predicting outputs for sensor number 3. And those are the results or data collected from the sensors over December 2018, as I remember. So as we can see, I don't know if you can see it, but the green line shows a drift in sensor 8, starting more or less from the 5th of December. And at the same time, we have between the 19th and the 22nd of December also sensor 3 failing. In general, the total number of faults we found in this data was more or less 4,600, but not just for this one, but over data that collected over that whole year, 2018. And now, this is, as I said again, the simultaneous sensor faults, where both sensors have faults at the same time between December 19 and 22nd. So here, where our models got adapted automatically, so model number 8 and number 3 got adapted, so all the data have been used in the input layer have been moved or shifted to the output layer, and then we created a new adapted model that predicts outputs for sensors 3 and 8. So in summary, that we can say that our approach is good in detecting, isolating, and accommodating sensor faults, not only for single fault, but also for multiple faults that happen at sometimes simultaneously. And for further research, what we want to do is we want to decentralize our approach. So instead of having all these models and all the training on a central computer of the monitoring system, we want to move everything to a decentralized manner and have everything inside the sensor nodes themselves. And what we also are looking forward to is to extend our approach to distinguish between structural damage and sensor faults. Thank you for your listening, and if you have any questions.